All right. Good morning, everybody. Welcome to a cold but sunny morning of Chem 1211 Lab with your host, me, Dr. White. And we're going to have a wonderful lab. And really, I'm going to get you out early. Okay. So, what are we going to talk about today? Well, we don't have a problem set because we haven't finished a chapter and you just had a test yesterday. So, what are we going to do? The lab. And boy, did I time it perfectly. Today's lab deals with chemical equilibrium, but more specifically, it deals with Le Chatelier's principle. Oh, wait, you don't know Le Chatelier's principle. Guess what? I'm going to teach it to you right now. Thumbs up, people. Do you see it on the screen? Thank you. All right, now, when we talk about equilibrium and a chemical equilibrium, as I taught you yesterday, let's look at the following. And here we have a reaction. A plus B makes C and D, and C plus D make A and B. This is a chemical equilibrium. At equilibrium, the forward and reverse rates are the same. The concentrations of this is equal to equilibrium constant. This one, KEQ, equals, since there are no coefficients other than number one, and this is a chemical equilibrium. Well, it turns out a great French chemist, Le Chatelier, and yes, I pronounce it with my North Side Chicago French accent. No, I don't do good French words easily, so I'll do Chicago accent. Le Chatelier's principle is when a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes that disturbance. What? Another way of saying it, if a stress, a changing condition, is applied to a system in equilibrium, the system will readjust, change the position of the equilibrium in the direction that best reduces the stress imposed upon it. Ah, wait a second. Now, everybody, take a deep breath, let it out. Take a deep breath. I like the hand motions. Let it out. I'm not even charging you extra for that. Let it out. Are you all nice and relaxed? Relaxed, and are you nice and relaxed now? Le Chatelier's principle involves relaxed use of logic. Relax, and some students aren't used to using logic. Now, as an organic chemist, we use a lot of logic a lot, so I'm quite comfortable with it. But pay attention, you'll get it. And also, don't forget, ask questions. All right, let's say you were at a party and somebody was talking to you and doing this while they're talking to you. I don't like that. I'm under stress. You go like this, stop that. You take action to reduce the stress. Well, a Chatelier's principle is the same way, except now you're dealing with molecules. Well, what kind of stress can we put on it? Let's take a look. One stress is by changing the concentration. And see board. Oh, I better get to work. Everybody see A plus B goes to C and D equilibrium? All right. All right. Generally, what you look at, what happens to the concentration of anything. Remember, this means moles of B per 1 liter or 1,000 milliliters, which is concentration. Now, before I go into this, I have to discuss something that students have trouble wrapping their head around. Let's assume you have a French silk pie. Like I need that with a hole in my head. But anyways, let's assume you have a French silk pie. Dr. White loves French silk pies. And what happens if you consume half of it? You're a real pig and you consume half of it. The pie you had, after you consume a lot of it, do you have the same amount of pie, more pie, or less pie in the pie pan? You have less. So when you consume something, you wind up with having less of it. Here I have some tea. By consuming it, i.e., that means that is drinking it, I now have less tea in my cup. So whenever you consume something, you have less. Now, let's assume you're making some cookies, which Dr. White needs like a hole in the head too. But say you're making some really nice chocolate chip cookies, and before you start, you have 0 cookies. After you make a batch of cookies, do you have the same amount of cookies, less cookies, or more cookies, assuming you don't steal any before they're cooled off? Well, you have more of them. So whenever you make something or produce it, you have more. If I were to make another cup of tea, would I have the same? No, I'd have more tea because I've produced it. So remember, when you consume something, you have less of whatever you consume. When you make something, you have more of it. I like those hand signals. Which way did they go? Which way did they go? Couldn't resist. All right, now let's look at the following. What happens to the concentration of B and D if all right, now let's talk about Le Chatelier's principle. At equilibrium, this one right here, there's a certain amount of A, a certain amount of B, and a certain amount of C and D, and that allows the equilibrium constant to always be a constant, which it is. Now, if I add more A, well, this isn't true anymore because, oh no, there's too much A. At equilibrium, there was a certain amount of A. Well, now there's too much. And now I'm under stress. I have too much A. Because why? We added some. You could either do it with an eyedropper or whatever. So, how do you get rid of the excess A? There's only one way. If A reacts with B, when something reacts, it's consumed. And that will lower the amount of A. Is everybody with me on that? Whenever we have too much A, we've added it. At equilibrium, there's a certain amount of A. Now we've added more, and the whole equilibrium goes, oh no, we've got too much A. We've got to get rid of it. The only way you can get rid of it is A reacts with B, because in that case, in a reaction, when you react two together, it's consumed. So if you react A with B, B is also consumed. So what happens when something is consumed? Remember my French silk pie. I'm going to buy one. No, I don't. Maybe in a couple months when I get rid of some of the weight I put on because of the pandemic. I've been trying. It's hard. But what happens when you consume some of A reacts with B? A is consumed, B is consumed, which means the concentration decreases. Or you can put an arrow down if you like arrow downs. Now, when A and B react, they make more C and D because that's how they're being consumed. Well, if you make more of something, what happens to the amount or concentration you have? Guess what? You make more of something, the amount you have increases. And C does too, but I'm only asking about that. And that's the Chattelier's principle. When an equilibrium is under stress, there's too much or not enough of something, it shifts, meaning it reacts in a direction to make more of what it's missing or consume what it has too much of. Let's do another one. Let's assume we remove some A. If you remove some, it has less than it should have. And the equilibrium, all the A, B, and C, and D, you know, they could talk to each other, say, oh no, we have too much, not enough A. How do we get more A? Well, if we look at the equilibrium, the problem is there's not enough A because we took some out. And how do we make more A? C and D react to make A and B. So if we make more A, what's going to happen to B? We're going to make more of it because we're driving the reaction this way. And therefore, the concentration of B will increase. And what happens to the concentration of D? If we look at D, C and D react to make more A and B because we need to make more A. When something reacts, it's consumed. Remember the French silk pie? I wonder how many times I can say that in the next hour. But anyways, what happens when something is consumed? Do you have more or less or the same? You have less. If you have 2 cookies and you eat one, do you have more or less cookies? Oh, by the way, in case you don't know, Dr. White loves those big smile cookies. Well, when you consume it, C and D are reacting to make more A, because you removed it, you're going to consume D. When you consume something, the amount you have decreases. Again, this is one of the tougher concepts I'll teach you. By the way, I could have put an arrow up here, decrease, arrow down. And that's Le Chatelier's principle. And guess what? That's happening in your lungs right now. Oh no, I just scared everybody. And I think it's either also happening either in your kidneys or your liver. One of those two also uses Le Chatelier's principle. And your blood uses Le Chatelier's principle. So why are you learning this? Well, your body's already using it. And the chemical industry will use it too. Let's do one more. And I'm going to let you try this one. Ah. What happens to the concentration of A and B if I add more C. Now, let me give you a pro tip. The concentration never stays the same. You got two choices. It either increases or decreases. So I add more C. What's the stress? Oh no, I have too much C. How do you get rid of C? I see a question or two. Yes, I'm talking about the equilibrium A plus B goes to C plus D. It's this question right here for this equilibrium, but now I have a new A, or part A. What happens to the concentration of B and D if I add more C? If you give up, throw your hands up and say, I give up. No.
Dr. White, I'm confused though, because if D increases,
All right, hold on. What are you confused about?
so going back to the first one, what you do in the numerator and denominator, right? So if you, are you saying that the,
All right, a better way is not to think about this at all.
okay,
Okay. Uh, in a way it does, but you'll find it's much easier. I'm going to even make it. Oh, come on. Hold on 1 sec. 2 sec. Let's erase this. Oh, I did. When you do Le Chatelier's principle, you look at the equilibrium and say, all right, what is the stress? And the one I just did is at equilibrium, there was a certain concentration of A, B, C, and D. If I add more C, it should have had a certain amount. Now it has more and it wants to get back to where it was. So how can it lower the amount of C? Too much C, it needs less C. Does that help, Ann? Let me do this one and we'll do a couple more. This is not an easy principle to wrap your hands around. Trust me, I've taught it enough times.
I guess because I'm putting numbers in there,
Now,
don't do that.
there's no numbers. This is all qualitative.
Okay,
The only two answers you will give on a question like this is the concentration either increases or decreases.
okay.
I've never seen where it stays the same, and I've never written a problem where that would ever be a correct answer. So let's do this one, and I'll give you another one. We got a bunch to do. All right, we have this equilibrium. A plus B is in equilibrium with C plus D. At equilibrium, there's a certain amount of A, certain amount of B, certain amount of C, and a certain amount of D. And they're all happy. You know atoms and molecules can be happy. And they talk too. Not really, but it sounds nice. Now, what happens, and I just picked these two arbitrarily, B and D concentration, if I add more C? Now, when I add more C, at equilibrium, there was a certain amount of C. Now there's more, too much. And it's under stress and says, woe is me. Or I could do an oy vey too, and says, I've got too much C. How do I get rid of it? There's only one way you can get rid of it. It can be consumed by being in a reaction. So if C plus D react to go that way, what happens to the concentration of D? If you're reacting it with C, it's consumed. When something is consumed, its concentration decreases. Goes down. You could use write that too. Now, to get rid of the excess C, C and D react. When they react, what happens? You make more A and B. When you make more of something, do you have the same, more, or less? Well, you have more. The amount you have increases. And what that does is it shifts the equilibrium. So the amounts are different, but they will still equal the equilibrium constant. But for these type of problems, you don't think numbers, you just think the logic I just told you. How do you remove the stress? What is the stress? Does that help? Well, let's find out if it does. Let's do another one of these. Ah, that looks better. Why don't you try this one? What happens to the concentration of B and D if I remove some C? Your turn. And don't forget, if you get a headache from Dr. White, ibuprofen or other painkillers are suitable to use. By the way, that's chemistry too. All medicine is organic chemistry. And don't forget, if you can, turn on your webcam so Dr. White can see your real people. Which makes me happy. It's good to get Dr. White happy. And when you're done, give me a thumbs up. Thank you, Gabriella. Thank you, Anne. And those who don't have their webcam, don't forget to use the emoji. Who came up with that word, emoji? I don't like it. I think I'm going to officially change the word emoji to symboli. All right, let's do this. What happens to the concentration of B and D if I remove some C at equilibrium? Let me clean this up. At equilibrium, there's a certain amount of C, A, B, C, and D. If I remove some C, there's now less C. And equilibrium says, oh no, we don't have enough C. We need more C. And how does it make more C? Well, there's only one way. A and B react to make more C and D. If I make more C, I'm going to make more D. What happens when you make more of something, like more cookies? Like I need like a hole in the head. But anyways, when you make more, the amount you have, in this case, the concentration, increases. And You can show it by an arrow too, or it gets larger. Now, how did you make more C when you needed it? You reacted A and B. When anything reacts, it's consumed. And remember my French silk pie, if you eat half of it, do you have more or less? And the answer is less. And therefore, if A and B react, A and B are consumed, the amount of B decreases. Goes down. And that's the Chattelier's principle. But wait, it gets more exciting. Temperature has an effect on certain equilibrium. And those are exothermic reactions and endothermic reactions. And remember, an exothermic reaction is a reaction that gives off heat as it proceeds, and an endothermic reaction is a reaction that you have to add heat to. Oh, see, bored. I've got to get to work. But before I do that, I've got to teach you something very fundamental that you probably know, but everybody see the whiteboard? And for this part, we'll be talking about heat. Now, how many of you have ever seen an ice bath? Well, what is an ice bath? That's a beaker of water with ice in it. Or if you have a glass of water with ice cubes in it, we could call that an ice bath. And if you put something in an ice bath, you make it cold. And what does that do? Oop. It removes heat. Whenever you make something cold, you're removing heat. If you go outside in the middle of winter without a jacket on, you're going to get cold. Why? Because the heat from your body is leaving you, and that makes you feel cold. So an ice bath, you should remember, removes heat. Now, if you have a pot or beaker of boiling water, and you put a reaction in there, what does that do? It adds heat. So this is something you should know, that an ice bath removes heat and a boiling water bath or boiling water adds heat. And everybody got that down? Ice bath removes heat, boiling water adds heat. So now let's look at the following. And now for the Chattelier's principle, we'll show heat. In this case, this is an exothermic reaction. And I could say, and I will, and the first one, let's do one you already know how to do. If I why don't you try this one first, and then Dr. White will show you how to do it. What happens to the concentration of E and H if I add more F? The stress says, oh no, I've got too much F. You didn't know equilibrium can do that. Go, oh no, I have too much F. Aren't you glad I'm not stuffy like, and today the equilibrium, you add F and now the concentration of F has increased. No, it's got too much F. I'm not even charging you extra for that. Oh, that reminds me, don't forget to make your donation to the Save Dr. White Foundation by putting a $100 bill under the rock by the nearest railroad station to you. It's Wacky Humor Thursday. That was pretty wacky. Remember, give me a thumbs up when you're done. All right, I think everybody's done. Let's do this. All right, I've added more F. I have too much F. Oh no, how do I get rid of the excess F? Well, there's only one way. E and F react to make more G and H. Now, when E and F react, both F is consumed, which lowers the excess, and E is consumed. When something is consumed, the amount you have decreases. Goes down. How does it decrease? It makes more G and H. Therefore, if you make more of something, the amount you have increases. This one Dr. White will do. What happens to the concentration of E and H if you put the reaction in an ice bath? Well, what does an ice bath do? You need to know this removes heat. Now, even though it's not an equilibrium constant, for an exothermic reaction at equilibrium, there was a certain amount of E, certain amount of F, certain amount of G, certain amount of H, and a certain amount of heat. What happens when we put it into an ice bath? Oh no, we've removed heat. And now the equilibrium says, oh no, we don't have enough heat. We've got to make more heat because someone removed some of our heat. Bad person. But anyways, so how can it make more heat? Only one way. E and F react to make more G, H, and heat. Is everybody with me on that? Therefore, if E and F react, what happens to the concentration of E when it reacts? It's consumed. it will decrease again. And to make more heat, we're going in this direction. And we make more G and H. When you make more of something, like more cookies, you will have more, and the amount you have increases. And that's how you use Le Chatelier's principle for an exothermic reaction. And I better let you have a chance to have some fun. Let me erase my mess on the screen. I just saw something evil. If I were lazy tomorrow, I'll just play this videotape for the class. That wouldn't be nice. All right, class, watch the video. I'm gonna go take a walk around the block. All right, let's take a look at this. It's your turn. What happens to the concentration of E and H if I put the reaction in boiling water? And I'm going to help you out. Boiling water adds heat. Your turn. Boy, time flies when you're having fun with a Chattelier's principle. Oh, you guys need to pick me up. And like I said, if you've been using your brain too much this morning and it hurts, take a painkiller after class. Oh, I should add 3 points each, like A, B, and C, and there'll be at least 9 points on test number 4 on this. And when you're done, give me a thumbs up so I can move my equilibrium. All right, I think everybody's done. So let's take a look at the new A. What happens to the concentration of E and H if you put the reaction in boiling water? Well, at equilibrium, there's a certain amount of E, certain amount of F, certain amount of G, and certain amount of H, and a certain amount of heat. Oh no, I've added more heat by putting it in the boiling water. What's the stress? Oh no, I have too much heat. I got to get rid of some of it because I'm under stress. Well, Chatelier's principle says the equilibrium shifts in the direction. How can I get rid of excess heat? Well, if it reacts with G and H to make more E and F. Since it's reacting with G and H, when something is reacted, it's consumed. H is consumed in that reaction, so the amount will decrease. Need I say French salt pie again? Now, G and H and heat react to get rid of the excess heat we added. And how does it do that? It makes more E and F. It's called, it shifts in the direction to the left. And if I make more of something, what happens to the concentration of whatever I make, such as E? It will increase. And that's how you do exothermic reaction. You know something? Let's take a 5-minute break now. This would be a good time. Come back at 9:50. I'll get you out of here before midnight today. Actually, by 10:30, we should be done, if not sooner. But let's take a break. I'll see you in 5, and I'll be back. You too, I hope. Time to start. Everybody back? Come back, wherever you are. All right, let's get going. Now let's look at an endothermic reaction. And in a little while, you'll understand what you'll be doing today's lab and why I'm explaining this to you. All right, let's look at the following. This is an endothermic reaction. How do we know that? Because we're adding heat. Heat is on the left side. That tells us it's an endothermic reaction. So the question is, what happens to the concentration of A and C if I put the reaction in boiling water? And you have it in a test tube and you stick it in a beaker of boiling water. First of all, you should know boiling water adds heat. And at equilibrium, there was a certain amount of heat, A, B, C, and D. Now I've added more heat and it's under stress. It goes, oh no, I have too much heat. I've got to get rid of some of this excess heat. I'm under stress. You can hear it even in my voice. Oh, that was awful. But anyways, it's under stress. So how does it get rid of excess heat? Heat reacts with A plus B to go this way to make more C and D. If I react heat with A and B, A is consumed. When something reacts, it's consumed. And if something is consumed, do you have more or less? You have less. So the amount of A decreases. It goes down. Now, remember to get rid of the excess heat, because we put it in boiling water, heat plus A and B react to make more C and D. If I make more of something, do I have more or less of it? And the answer is more. Therefore, the amount you have, the concentration, increases. And that's how it works. And your turn. And the question is, what happens to the concentration of A and C if I put the reaction in an ice bath? Dr. White's going to be nice now and tell you ice bath removes heat. Your turn. Remember, stuff like this is going on in your body. By the way, I charge extra when you have people walking behind you.
That's where the real money comes in, when people walking by.
Yeah, really. I get to do a tax, a toll. I'm going to put up toll booths. Nah, I'd rather just sell bridges in downtown Chicago. Anybody want to buy one? Well, I think everybody's just about done. Let's do this. All right, let's look at this reaction. It's an equilibrium. Double-headed arrow tells us that. At equilibrium, there's a certain amount of heat, certain amount of A, B, C, and D. I put it in an ice bath, and it says on the screen even, you've removed heat. So now what's the stress? At equilibrium, there should be a certain amount of heat. Now there's less. Oh no, I need more heat to replace what somebody took from me. How do I make more heat? C and D react to make more A, B, and heat. So it shifts this way to make more heat, but at the same time, it makes more A and B. Well, if I make more of something, do I have less or more of it? You have more of it, which means the amount you have, the concentration of A and also B, but you're only asked about A, increases, goes up. Now, when C and D react to make more heat, C and D are consumed. That's what happens when you react something. Just like if you eat part of the French silk pie, do you have more or less of something when it's consumed? And the answer is less, which means the amount decreases. And that's how you do Le Chatelier's principle for endothermic reaction. When the heat is on the left, you add to it. Now, if I did add more A, what happens, or add more B, what happens? That's the same as we've already done. Now you're ready for today's lab. Wrong one, right one. All right, everybody see Le Chatelier's principle lab on there? Well, I've already told you an equilibrium, when you have two opposing reactions, the same forward and reverse rate. And when you're considering equilibrium, it's important to consider exothermic reaction. When the heat is on this side, that means it's given off as the reaction goes to the right. And endothermic heat is on the left. And this important principle for equal is Le Chatelier's principle. And I say what it is here. And when changing conditions by adding or removing reactants, products, or heat will change the concentrations. If you put a reaction in boiling water or adding heat, if you put a reaction in ice water or ice bath, you're removing heat. In this lab, you'll be examining the effects of adding reactants and products on the equilibrium reaction. You'll also be examining the effects of adding and removing heat. When you do this, you'll be able to determine if the reaction is exothermic or endothermic, equilibrium reaction. Now, let's look at part one. Here is the equilibrium. Let me ask, everybody see part one on your screen? Thank you. Now, when the equilibrium is on the left, shifting to the left, the color in the test tube is blue. When it shifts this way, it's pink. Now, either on this side or this side will be plus heat. Today's lab, you're going to find out and determine by a series of experiments which side is the heat on for this reaction. And at the part of the question is to rewrite this cobalt tetrachloride plus water, 6 waters gives you cobalt hexahydrate plus 4 chloride anions, and either on this side or this side will be plus heat. How do you do that? By observing which way it shifts based on the color. And here you'll start out with the equilibrium, record the color. Then you'll add 5 drops of DI water. DI stands for deionized, meaning there are no other ions. When you add water, there's too much water, and the equilibrium should shift to this right side and should get pink. Now, when you add the 12 molar, and you know what that HCl, this is really adds in water becomes H plus and Cl minus. We'll learn that. Adding HCl, 12 molar HCl, should add more Cl minus. Adding more Cl minus will now shift it to the left, and it should become blue. And you'll find out if that's true or not. It is. And then here's what you don't know, and you'll have to look. I have the data. Put the test tube in an ice bath. After 2 minutes, record it. And before you do that, put it in a beaker of boiling water, record the temperature, the color, and then put it in an ice bath and observe the color. Now, here's the data. Let's take a look at this reaction. Everybody see the colored test tubes on there? And you can go back and look at this at your leisure. Oh, by the way, you can also show your kids it. They'll love it. Watch what happens to the test tube color when you add water. It stays that sort of pink color. Now we're going to add the HCl. Oh, look, it turned blue. Is that cool or what? Isn't chemistry exciting? Now, look what happens when you put it in the ice water. And the same reaction you put it in cold water. And if we wait a little while, Notice in the cold water, it's staying pink, and in the blue one, in the ice bath, it turned blue. And that's the first part of today's lab. Let's go to the second part. And again, you're going to be doing an equilibrium. Does everybody see ammonium chloride equilibrium on your screen? On this one, ammonium chloride, NH4Cl, is a solid. And when it's in equilibrium on this side, on the right, NH4 plus and Cl minus, it's clear, it's dissolved. And again, you've got to figure out which side of this equilibrium you put plus heat. In other words, like the previous one, and I won't give it away, does the plus heat go here? Or does it go on this side? And by understanding which side they will be shifted, you'll know. Now, first of all, you'll take some ammonium chloride solution in a test tube, and you'll observe, is there a solid present or not? Which side is the equilibrium? You'll add 5 drops of the HCl solution. Remember, this is adding Cl minus, and you'll mix it and record whether or not you have a solid present. If you have a solid present, that means you shifted to the left. If there's no solid present, it's on the right. Then you'll put it in boiling water and observe, is there or not a solid? And you'll put it in an ice bath. I don't have a video for that, but here's the data. It's like I have the data up here for the previous one. And then there are a series of questions. And then the most important one, write the equilibrium equation for part 1, and please include heat on one of the sides. Now, can you keep a secret? Dr. White's going to do something real nice for you. Everybody see chemical equilibrium help sheet? In the lab today, in the assignment area, you can download this. And notice, what do I have in part 1? Add water increases the 6H2O. Adding the HCl increases this. Putting in water adds heat. Puts in ice removes heat. That's my little gift to you. And same thing for part 2. Adding HCl increases this right here, and putting it in boiling water adds heat, and putting it in ice removes heat. Remember, let me give you a little hint. If I put it in boiling water, we add heat, therefore the equilibrium will shift to the side without the heat. When I put it in boiling water, since you add heat to get rid of that, the equilibrium will shift to the side to the color without heat. When I put it in an ice bath, you're removing heat and it wants to make more heat. So when you put it in an ice bath, the equilibrium will shift to the side, the color or clear or solid that adds heat, that has the heat. Ice bath shifts it to the side with the heat, boiling water without. And that's my little help for you. That's a big help, because I did that, because before I did that, when we do this lab face-to-face, students were like, lost totally. I don't know if they want, but they were like, I don't know what to do. And that sheet will help you so you don't have to, I don't know what they have to do. And remember, what's Dr. White's policy on questions? All questions are good questions, or as I like to say, there's no such thing as a dumb question. So if you're having problems with it, always feel free to come to my office hours next Monday and Wednesday on your favorite Zoom channel with Dr. White. And with that, I'm done. I told you I'd get you out early today, and I did. So with that, I'm going to say, gang gesund, be healthy. I'll see you on Monday. You have a nice rest of the week. I'm going to be grading tests tomorrow and Saturday and labs, but you're worth it. I should use multiple choice because it's quicker, but nah, I don't like multiple choice, all multiple choice tests. So with that, gang gesund, bye, as Granny would say.
Have a good one.